Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about integration by parts.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, the integral of x e to the x dx, and we're given the u value of x and a dv value of e to the x dx, and we want to evaluate this indefinite integral. Now, one thing that's nice, they already gave us our u and dv. So we need to find our du and v. So to find our du, we want to take the derivative of, well, u, right? So the derivative of x is just going to be a 1 dx. Pretty easy. The integral here of dv, okay, well, the integral of e to the x is just e to the x. Now, don't worry about the plus c when we deal with that later, okay? We know we'll have to have a plus c. So we have it all set up, and now we have to use our formula for integration by parts. Okay, so we follow it. It says the integral of u dv, so we set our dv to be e to the x dx, right, is equal to, okay, our u value, which is x, times our v value, which is e to the x, minus the integral of v, which is e to the x, and then du, which is 1 dx. Okay? And now we have to, well, solve again, keep going. Now, this is a little easier here, right? Because 1 multiplied by 1 dx is just multiplied by dx, right? And so here, pretty easily, we have x e to the x here, minus, and what's the integral of, well, e to the x? Just e to the x. Don't forget the plus c right here, and we're done. Not too bad. Our final integral here and answer is x e to the x minus e to the x plus c. We're given this problem right here, the integral of x cosine x dx, and we're given the u value of x and dv value of cosine x dx, and we have to evaluate this indefinite integral using integration by parts. So since we already have our u and dv, let's go find our du and v. So our du value here, the derivative of x, is just a 1 dx. Pretty easy. If we're going to find our v value, we're going to integrate our dv, and the integral of cosine of x is a sine of x. Right there. Okay? Now, from here, we're going to apply our formula. Our u value is x, and cosine x dx is our dv. So to do that, it says, okay, we have it all lined up, all right, everything going here. U, which is an x, times our v value, which is a sine of x, minus the integral of v, which is a sine of x, and du, which is a 1 dx. Okay? And this one actually now makes it a little easier. Okay? So we keep going. We have x sine of x here, minus, now here it's multiplied sine of x times 1 dx, or sine of x dx. And what's the integral of sine of x? Well, that's a negative cosine of x. So we have a negative cosine of x right here. Don't forget the plus c now. We have to have one at the end. And let's just rewrite this to be nice and neat. X sine of x plus the cosine of x plus c. And so there we have it. Our final answer is x times the sine of x plus cosine of x plus c. We're given this problem right here, the integral of x times 2 to the x power dx, and we're given a u value of x and a dv value of 2 to the x dx, and we have to evaluate this indefinite integral using integration by parts. Now we're already given a u and dv value, so let's go find our du and v value. Du, the derivative of x, is just 1 dx. Now the integral of dv, being v here, the integral of 2 to the x dx is a 2 to the x over natural log of 2. Okay? Now, we don't write the plus c right here. We're going to deal with that in a little bit. Okay? So now we have all of our parts lined up. Let's go use our formula here. So our u value being x, and dv right here is 2 to the x dx. We say, okay, u is x times our v value, which is 2 to the x over the natural log of 2, minus the integral of our v value, which is 2 to the x over natural log of 2, du, which is a 1 dx. Okay? All right. So then from here, we're going to try to take that integral right there. And the way we want to do it, okay, I'm going to pull out that constant right here. So we're going to rewrite this. We have x, 2x, 2 to the x power, over the natural log of 2. I combine that, minus, I'm going to pull out the natural log of 2 and make it a little easier to see, times the integral of 2 to the x power, right, dx. Simplify, don't need the times 1. Now luckily for us, we already found what the integral of 2 to the x was. It's right here, 2 to the x over natural log of 2. So continuing that out here, okay, how much space do I have? Let's do one more down. Well, I can slide it over here. We have x times 2 to the x power over natural log of 2 minus, right, 1 over natural log of 2 times the integral of 2 to the x dx, which we said was 2 to the x over natural log of 2. And then we have a plus c. All right. Now let's go simplify this up a little here. We have a x times 2 to the x power over natural log of 2 minus, combine this, we have 2 to the x in the numerator. The denominator is natural log of 2 all squared. And then with plus c. And that's it. My final answer here for this integral is x times 2 to the x power over natural log of 2 minus 2 to the x power over natural log of 2 squared plus c. We're given this problem right here, the integral of the square root of x, natural log of x dx. And we're given a u value of natural log of x and a dv value of the square root of x dx. And we have to evaluate this indefinite integral using integration by parts. Now we're already given a u and our dv value to use here. So let's go find our du value first. Natural log of x, the derivative of that is a 1 over x dx. Now the integral of dv we need to find, remember, square root of x is x to the 1/2 power. So the integral of square root of x is a x to the 3/2 power, and we put a 2/3 out front. Right here. And then don't forget, we're not going to do the plus c yet, we'll add it later. Okay? Do forget it right now. Alright, so from here we have our u, du, our v, and dv values. Let's use our formula. Okay? So our formula says we have a u times a v, so our u value is natural log of x, and our v value is 2 times 2/3 times x to the 3/2 power, minus the integral of our v value, which is a 2/3 x to the 3/2 power, right there, times du, which is a 1 over x dx. Okay. So from here, let's go see if we can simplify things out and pull out what we can. Okay. Now, right here, let's combine it as one fraction. We have, which one I put first? I put a 2. So we have 2x to the 3/2 power times natural log of x over 3 minus. Now here where it gets a little tricky, I'm going to pull out the 2/3. Okay, pull out the 2/3, and let's simplify the inside. We have x to the 3/2 power divided by x, so we really have x to the 1/2 power dx, right there. Okay, and this actually makes it a lot easier, right? Because remember, x to 1/2 power is the same as the square root of x. So continuing on, we need to keep going. So this stays the same. We keep it out here. 2x to the 3/2 times natural log of x over 3 minus 2/3 times the integral of x to 1/2 power, which we already found. All right, hard work's already done in the beginning. We have 2x to the 3/2 power over 3 plus c. Don't forget the plus c. And now we just want to simplify this out a little here. Okay, so again, the front part just stays the same. Okay, we have a 2x to the 3/2 power times the natural log of x over 3 minus, combine it, we have 4 in the numerator, x to the 3/2 power over 3 times 3 is 9 plus c. And just double checking, I got it right here, making sure everything lined up, and we're good. So our final answer here is a 2 times x to the 3/2 power, natural log of x divided by 3, minus 4 times x to the 3/2 power over 9 plus c. We're given this problem right here, the integral of x times e to the negative x dx. We have to evaluate this indefinite integral using integration by parts. So let's go find our u and dv value. Our u value, let's go figure that out. Let's go set u to be, what do I have u to be? Let's say u to be our x value, and our dv value, okay, is a e to the negative x dx. So we have the whole integral covered. So with that being said, our du is a 1 dx. And our v value, the integral of a e to the negative x, is a negative e to the negative x. Okay? So we have all that kind of laid out. That's the hard part. Now we use our formula here. So this is equal to the, not the integral, equal to u times v first, so u being x, and a v value is a negative e to the negative x. Then we subtract here the integral of our v value, which is a negative e to the negative x, and our du value is a 1 dx. Okay? Alright, so before we keep diving in, let's go simplify this out a little bit. Okay, and it should look kind of familiar here. We have x times negative e to the negative x, so we can rewrite this, okay, rewrite this out here to be a negative, negative x times e to the negative x power, and you'll see why in a minute. Later it'll simplify better. Pull out the negative here, and we have two negatives become a positive, and the integral of e to the negative x. And then 1 times dx is just that dx. So now we still have to integrate e to the negative x. Well, luckily for us, we already did that from dv to v. So keep on going with negative x e to the negative x plus the integral of e to the negative x power is a negative e to the negative x power. And then we have a plus c here. Okay, but now we can actually simplify this a little bit. Okay, we can pull out an e to the negative x from both sides, and we have a negative x, well, subtracting, right? Plus minus here is subtracting 1, all times e to the negative x plus c. And then with that being said, let's go make this into a fraction, make it nice and neat. We have a negative x minus 1 over, remember, e to the negative x is the e to the positive x in the denominator plus c. And so my final answer here is just a minus x minus 1 over e to the x plus c. We're given this problem right here, the integral of x squared cosine of 3x dx, and we have to evaluate this indefinite integral using the integration by parts. Now, we first want to find a u and a dv value. So given this problem right here, I'm thinking I'm going to put my u value to be x squared and my dv value to be cosine of 3x dx. So with that, we need to find a du and a v value. So the derivative of u, so du is a 2x dx. Integral of dv, so the integral of cosine of 3x, is a 1/3 sine of 3x. Okay? So let's go with this and let's go apply our formula here. We have a u and a dv value written right here. Okay, and this is a cosine of 3x if you haven't noticed that, right? Little parentheses here. Okay, so u times v, u, x squared, v value, right, is 1/3 sine of 3x, subtracted by the integral of our v value, which is 1/3 sine of 3x, times our du value, which is a 2x dx. Okay. So let's go simplify this where we can, okay? Simplifying it out, we're going to pull out, or combine this to be a fraction, so we have x squared times the sine of 3x here, over 3, minus, I'm going to pull out that 1/3, or actually 2/3, right? The 2 here and the 1/3, so we have a 2/3, comes out, let's pull out the constants, and we're left with, again, kind of rearranging this, an x times the sine of 3x dx. And this one's a little tricky. It's like, well, wait a minute. We already did our our u, du, v, dv, and we still have another thing that doesn't really look neater. Well, let's go do it again. All right, let's do it again. Who says we can't integrate by parts a second time? So let's set our u value here to be an x, the first one, and that makes our du equal to 1 dx, pretty good. Our dv value is the sine of 3x dx. And that makes our v value, well, the integral of sine of 3x is a negative 1/3 cosine of 3x. Okay? Apply that again here. Okay, so we keep everything over. Let's try to write a little smaller so we can save everything. Sine of 3x over 3 minus 2/3 stays out here. But now we're going to apply our formula, and I like to put a little bracket here to show that a 2/3 needs to apply to everything. All right, so the integral of x sine of 3x dx, we're using our formula. Our u value here, and this time, is just an x value. So we have x times our v value, which is a negative 1/3, cosine 3x. Then we subtract, right, by the integral of a v value, which was a negative 1/3, cosine of 3x. And our du value here is a 1 dx. And it's nice and neat now. And don't forget the close bracket. Okay, so what we're going to do is, I'm going to kind of do a lot of steps in once here. So we have x squared minus the sine of 3x, that's a 3, over 3, minus, we're going to distribute this 2/3 to both parts as we keep going here. Okay, so 2/3 times a negative 1/3 gives us, oh, it's a negative 2/3, sorry, times a negative 1/3, almost messed that up there, and we have a 2/9. So we have a 2 in the numerator, we have x cosine of 3x, don't forget the 9th in the denominator, plus, now notice I said plus, I want to pull out that constant, negative 1/3 comes out here, right, or, sorry, negative 2/3 times a negative, here is a positive 2/3, this is why I did it, then we're going to pull out that negative 1/3. Now the integral, ignore that negative 1/3 here, the integral of cosine of 3x, well, we already found that, that is a 1/3 sine of 3x, right here, and then we have a plus c. Okay, all this work, let's see if we can fit it in up here. Okay, so we have an equal sign, so it all kind of fits. Hopefully you can get it all in there. Again, the beginning's the same. I have to do 2 lines here, but take your time. X squared minus the sine of 3x over 3 minus. The second one stays the same, 2x times the cosine of 3x over 9. And I'm going to go off, so I'm going to add it here. So remember, this is all one function here, or equation. We multiply this out. We have 2 times a negative 1 times a 1 is a negative 2, so we have actually minus here. We have minus a 2 sine of 3x over our denominator, 3 times 3 times 3, 27, plus c. And so all of this is my final answer. X squared minus sine of 3x over 3 minus 2x times the cosine of 3x over 9 minus 2 times sine of 3x over 27 plus c. We're given this problem right here, the integral of x squared over e to the 2x dx, and we have to evaluate this integral using the integration by parts. So we first want to set a u and a dv value. I'll set my u value equal to the numerator, x squared, and my dv value equal to, well, 1 over e to the 2x power dx. And we know that's the same thing as e to the negative 2x power dx. Okay, so keep a note of that. Well, we have this all set up now, so let's go find a du value first. Derivative of x squared, the 2x dx. The integral of our dv value, so the integral of e to the negative 2x, that's why I write it like that. So our v value is a negative 1/2 e to the negative 2x power. So right there. Okay, so now let's go apply our formula here. So we have our u times our v value, so x squared times our v value, which is a negative 1/2 e to the negative 2x power. Okay, got that there, minus our integral of our v value, which is a negative 1/2 e to the negative 2x power, times our du value, which is a 2x dx. Well, let's go simplify this where we can. Bring this down. We have here, oh, it's going to be a negative, so we have negative x squared in the numerator. And the denominator, we actually have the 2 comes down, and we have e to the positive 2x power. Put that in the denominator here. The subtraction, let's go pull out our constant. A negative 1/2 comes out, makes it a positive. So we have a plus right here, a positive 1/2 outside. Inside, let's put the 2x first. Oh, see, this is what I always do. I always do something like this, right? Let's simplify that out. I almost forgot the 2 right there. So we pull out a negative 1/2 and a 2. They cancel out. And we're left with, well, just a positive 1 out front, which is great. Then we have the integral of a x times e to the negative 2x power dx. Okay. So at this point, you might be a little confused on how we can integrate this. Okay. Well, we need to do really a u substitute, or u integration by parts again. U dv du v. Okay. So let's go set our u value to be an x here, and that makes our du value to be 1 times a dx. Pretty easy. Our dv value, the second part, again, is e to the negative 2x power dx. Separate the comma here. And that makes our v value something we've already found. It's the same thing, right? Negative 1 over 2, e to the negative 2x power. So from here, we need to do integration by parts again. So we have a negative x squared over 2 e to the 2x power. And, well, we're going to use our formula again. U value being x times our v value, which is a negative 1/2 e to the negative 2x power, right? Minus the integral of v, which is at, again, negative 1/2 e to the negative 2x power, times a du, which is a 1 dx right there. Okay? All right. So let's go. I'm going to rewrite this up here. Hopefully we have the room. Let's see if we can get this put somewhere. Rewrite the first part. We have a negative x squared over a 2 e to the 2x power. Now, plus, well, we can subtract now. We have subtraction sign going here, so it's being subtracting here. Our x is in the numerator, so we have x e, oh sorry, e is going to go to the denominator in a second, you'll see. So we have an x here over the 2 stays in the denominator, and we bring the e to the negative 2x power to the denominator, e to the positive 2x power. Then, this integral here, we'll pull out a negative 1/2, so we have positive 1/2 on the outside. And so the integral of e to the negative 2x, we've already found. That is a negative 1/2 e to the negative 2x power, and we don't forget the plus c. So all the calculus is done now. Let's go simplify this out a little. Negative x squared over 2 e to the 2x power minus x over 2 e to the 2x power plus, or actually minus, sorry, 1/2 times 1/2 is 1/4, but it's a minus here. 1 over, we have 4 in the denominator, and then e to the positive 2x power plus c. Now I think I can make this all into one big fraction. We just have a common denominator. This whole part right here, this section right here, notice it's very close. 2e to the 2x, 2e to the 2x, 4e to the 2x. So we multiply all that by a 2 over 2, if you can, like that. Kind of see that. We then have a negative 2x squared minus a 2x minus a 1 over a common denominator of a 4 e to the 2x power, and then we have our plus c. Make sure we're good, all good. And so my final answer here is a negative 2x squared minus 2x minus 1 over 4e to the 2x power plus c. We're given this problem right here, the integral of x squared times e to the 5x dx, and we have to evaluate this indefinite integral using integration by parts. Well, we want to find a u value and a dv value to start off with here. So I set my u value to be my x squared and my dv value to be that e to the 5x dx. So let's go find a du value. Du here, derivative of x squared is a 2x dx. And my integral of dv, okay, is going to be a v, and is a 1/5 e to the 5x power. Alright, so we have everything lined up. Let's apply our formula here. We have a u times a v, so an x squared times my v value, 1/5 e to the 5x power, minus the integral here of v, a 1/5 e to the 5x power, and then our du value times a 2x dx. Alright. Well, let's go simplify this where we can. Let's combine this to be one fraction. We have an x squared times an e to the 5x power over 5 minus, let's go pull out what we can. We have 1/5 and a 2, so it's minus a 2/5 on the outside, times the integral of, let's put the x out front, x e to the 5x dx. And notice this actually looks very similar to our beginning part, okay, our beginning integral. And it might seem that we're not getting anywhere, but we are. we actually need to do the integration by parts again. So let's go set a u value to be the x and a dv value again to be that e to the 5x dx. That makes our du value here to be a 1 dx, which is great. I love when I see that. And our integral of dv we've already found. Just keep everything organized. 1/5 e to the 5x power. From there, let's go apply our integration by parts a second time. This part just stays the same, x squared e to the 5x over 5. Minus, well, the 2/5 stays out here. But we're multiplying that by integration by parts, our formula. U times v, in this case it's x, times my v value, which is a 1/5 e to the 5x power, minus the integral of v, which is a 1/5 e to the 5x power, times our du, which is perfect, just that 1 dx. Okay, put parentheses there. Okay, so let's go simplify this again a little more. We have x squared times e to the 5x over 5. Minus, let's distribute this out here. So, 2/5 times a 1/5, okay, gives me a 2 over 25. So 2 in the numerator. We have x e to the 5x over a 25. I'll make sure I have everything right. And we're good. Plus, now we have a negative times a negative is going to be a positive. We have a positive, and 2/5 times a 1/5 will be that 2 over 25 again. We're going to pull out the 1/5 out here. So 1/5 comes outside, multiplies by the 2/5, positive 2 over 25, times the integral of e to the 5x, just a dx. All right, let's continue this up here. Again, the first part is just going to stay the same. You always have to just keep writing it. X squared e to the 5x over a 5 minus a 2x e to the 5x over 25 plus, all right, I'm going to put 2 over 25 here. Let's find the integral of e to the 5x, and we've already found that, which is great. A 1/5 e to the 5x power, and don't forget the plus c now. It's our last integral. So now we can just combine this, or simplify it a little bit. It's just algebra at this point. X squared e to the 5x comes down over 5 minus 2x e to the 5x power over 25. All right, got everything lined up here. Plus 2e to the 5x power, right? 2 times 1 times e to the 5x over 2 times 25 is 125 plus c. And after all of that, we have our final answer. Our final answer here is x squared e to the 5x over 5 minus 2x e to the 5x over 25 plus 2 times e to the 5x over 125 plus c. Given this problem right here, the integral of natural log of x plus 3 dx, and we're going to evaluate this indefinite integral using integration by parts. Now, this is actually a fairly tricky problem, okay? And so we're going to take our time through it. I'm going to actually rewrite this to be a, in terms of u and a du, okay? So first I have a u value of an x plus 3 and a du value of just the dx, okay? So with that being said, we're going to apply that here, and we have this equal to the integral of natural log of, well, a u du, okay? And here is actually where I apply my integration by parts. And I'm going to be using u and du and v and dv here, but we'll eventually we'll come back and replace it with x's when it's all said and done, okay? So bear with me here. And I purposely kept the same letters because I know we're used to using u substitution here and integration by parts with u and v, so I thought it would be easier this way. So u here, let's set that equal to the natural log of u, and that my dv is equal to just my du value, okay? That makes my du value here, derivative of natural log of u, is just 1 over u du. And my dv value, or sorry, my v value, integral of du, is just a u, okay? So again, apply the formula, and when you think of the letters of the formula, just think of the left-hand side of these equal signs, okay? So, take our time here. U times v, u, natural log of u. My v value is a u, minus the integral of my v value, which is a u, right here, v value being u, times a du, which is a 1 over u du. Okay? Now, at this part here, well, let's simplify this out a little bit. I'm going to put the u up front because it's a little easier to see. U, if I can write a u, natural log of u, minus, well here, the integral, we have u times 1 over u, that's just the integral of 1 du. Okay? Well, if we're integrating with respect to du of 1 is just a u value. So here we have a u, natural log of u, minus another u, right? Integral of 1, bu, of du, plus c. Okay? So now at this point, we have the integral done. We're going to bring back our x plus 3 in for this u. Okay? So instead of u, I have an x plus 3. So I have an x plus 3 here, times the natural log of an x plus 3, right? That second u, minus x plus 3 plus c. Okay? Now I'm going to do some simplification here. I'm going to multiply this natural log of x plus 3 to both parts here, of the x plus 3 right there. So I have an x, natural log of an x plus 3, plus 3, natural log of an x plus 3. Then we have a minus an x, distribute this out, minus 3 plus c. And this is pretty confusing at this point, kind of leading everything into it. But notice we have a constant and then, or a constant of negative 3 and plus a c. And plus a c is representing any constant that we're adding. So we can rewrite this whole thing minus the x, but instead of a minus 3 plus c, we don't really need that minus 3. That constant is just any constant, and so it can be a constant minus 3, it's the same thing, it's just some constant, we don't know what it is. So we can really write this as just a plus c. And that's it. My final answer here, after it's all said and done, is x times the natural log of x plus 3 times the natural log of x plus 3 minus x plus c. We're given this problem right here, the integral of cosine of 2x times e to the negative x power dx. And we have to evaluate this indefinite integral using integration by parts. And this one's a pretty difficult one. So let's go set my u value here and my dv value. I'm going to set my u value to be e to the negative x, and my dv value to equal to cosine of 2x dx. Okay, let me put parentheses there. So that makes then my du value, my derivative of e to the negative x, to be a negative e to the negative x dx. And we find the integral of our dv value, so our v value, and the integral of cosine of 2x is a 1/2 sine of 2x. Okay. So we have all that set up. Let's apply our formula. We're going to take our time here. We have a u times a v. U value, e to the negative x, times my v value, 1/2 sine of 2x, minus the integral of my v value, which again, that 1/2 sine of 2x, times my du value, a negative e to negative x dx. Okay. Well, what I'm going to do now, see, I see another integral here, and it almost looks more difficult. But let's go pull out what we can and see what we can do. So, we have here, let's go rewrite this as a single fraction. We have sine of 2x in the numerator. Okay, make sure I'm on the right part here. Over 2 in the denominator, and instead of e to the negative x power, e to the positive x power. Now, we have minus, but we have 1/2 comes out front, and this negative sign. So it becomes a positive 1/2 out front, times the integral of sine of 2x times e to the negative x power dx. Now, I know you're looking at this, you're like, well, how is this any different than what we have right here, right? I mean, we have sine and cosine, but it seems like it's not going anywhere. But don't give up hope yet. We need to do integration by parts again. And I know what you're also thinking. Well, it's just going to turn that sine into a cosine, and it will. We'll see what happens. It's actually a pretty cool trick at the end. So we have a u value here. Let's set it again to be that e to the negative x. All right, and we're going to set our dv value here to equal our sine of 2x dx. Okay, so du, again, same as before, it's a negative e to the negative x power, And our v value here is a negative 1/2 cosine of 2x. Okay? All right, let's keep all the ducks in a row and separate that out here. Okay? So, keep on going, taking our time, repeating the same process over again. Sine of 2x here over 2e to the x power plus, all right, the 1/2 stays out here, and we're going to do our integration by parts here, and I'll put it in brackets. U times v, u in this case is e to the negative x power, times my v value, negative 1/2 cosine of 2x, minus the integral of v, which is negative 1/2 cosine of 2x again, times my du, which is a negative e to the negative x. And then we still have our dx at the end. Oof, that's a lot here, okay? Make sure I have it all right, yeah. All right, looks more complicated. It eventually will simplify out, I promise. So we have the sine of 2x, let's rewrite that down, over 2e to the x power. Now I'm going to distribute this 1/2 across the board here, okay? So distributing that across to both parts here, what do we have? 1/2 times the negative 1/2 is a negative 1/4, right? So we have minus sign, we'll have 4 in the denominator, okay? Then we have a cosine of 2x in the numerator, and we're bringing that e to the negative x down in the denominator, be e to the positive x power, okay? Minus. The 1/2 comes over here, and we're going to actually pull out, okay, this other 1/2 out here. So we have 1/2 minus minus makes it a positive 1/4, but then this negative comes out, which makes it a negative. So we keep the negative sign here, 1/4, times the integral of that cosine of 2x, right, the 2 here. If I can rewrite it, I erased too much. So we have the integral here of a cosine of 2x, right there, times e to the negative x dx. Okay. Now if you're like me, you're like, okay, we are back at the beginning, right? We literally have the same integral from the beginning. What can we do? But notice here, this is equal to that original integral, this whole thing. So if we rewrite this, I'm going to try to write it small so it all fits out right here, okay? Actually, let's do it like this. This is equal to the integral of that cosine of a 2x times e to the negative x dx, right? Just set it equal from the beginning down here. But what happens if we actually add that to both sides? We add this 1/4 of that whole thing. Remember, this is all one big integral. We can do that. So I'm going to add that 1/4 integral of cosine, here's the trick, 2x times e to the negative x dx to both sides. Add it again. 1/4 integral, if I have the room, cosine of 2x times e to the negative x dx to both sides. What happens? Let's go, that whole thing we're putting up here, okay? Add it to both sides, will bring us back to the left-hand side to make it easier to see. So we have a coefficient of 1, really, right? 1's out front. And 1/4, that gives us a 5/4. So we have 5/4 times the integral of that cosine of 2x times e to the negative x dx. And that is equal to this whole part right here. That's sine of a 2x over 2e to the x power minus cosine of a 2x over 4e to the x power. Okay? Got all that lined up here. Okay, make sure. I would hate to make a mistake at this point. Okay? Why do I have a 2 sign? 1/2. Oh, no. Just double checking everything here. Okay, that's fine. Alright. So, as we're going, I'm actually going to combine these to be one big fraction. So let's keep this down. 5/4 integral of cosine of 2x e to the negative x dx. If I multiply this one by a 2 over 2, put that in, we then combine 2 times 2 is a 4, 4e to the x in the denominator. So we have a 2 sine of 2x minus a cosine of 2x over that 4e to the x power. Okay, But I want to get this original integral by itself. So just multiply both sides by a 4/5 to both sides. And that's why I combined it to be one fraction at this point. So the 4's cancel, 5 cancel. Great. We have our integral of cosine of 2x, e to the negative x here, dx. And that's equal to, well, the 4's cancel. That's great. And we're left with a 2 sine of 2x minus cosine of 2x over 5 e to the x power. And that's it. Beautiful. After all our big tricks kind of going around, the last one was the biggest trick of them all. But we got a final answer. Our final answer here is 2 times the sine of 2x minus cosine of 2x over 5e to the x power. Oh, plus c. Plus c. And add the plus c's. You can do it at this point if you want here. Plus c, plus c. But anyway, almost forgot the plus c. Anyway, plus c at the end. That's our final answer. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.